Welcome, everyone. I'm going to be talking about continuous security for your cloud environments. So if you're using AWS, Azure, or GCP, or Google Cloud, we'll talk about how to secure it. You probably have workloads there. You have data there that needs to be secured. And we'll go through some of the tools that Palo Alto Networks has, as well as give you an idea whether you choose us as a vendor or if you choose another vendor. Just how do you think about security for these public cloud environments, right? So before I start, I just wanted to gauge on how much of adoption that you guys, how much are you guys adopting cloud today? Quick show of hands, how many of you guys are using AWS? All right, almost half the audience, or over half. What about Azure? Wow, okay, expected, but definitely close to 75% of the audience. And what about Google Cloud? Some of you bold people, yeah, perfect. That's great. Obviously, Google Cloud came into this game a little later, but they've been innovating quite a bit. They have an infrastructure advantage. They've been running Google.com for so long. And all these providers, essentially, like Amazon and Google, both kind of did the same model where Amazon had this very large retail side of their business, and they were running very large infrastructure for a very long time, converted over to a service for you guys, and that allowed them to kind of have a whole separate business, which by now, actually, AWS is a bigger part of their business than Amazon.com itself, right? So nobody expected that. Google's doing the exact same thing, right? So they had this huge Google.com search infrastructure, data center spread across the globe, and now they get to reuse that infrastructure and all the best practices they were using to provide that infinite scale, and they're doing that as well. So to me, Google actually has a huge advantage from a network and an infrastructure standpoint, a fairly newer infrastructure, and so they're going to be doing a lot of innovation on this space. So I'm actually looking forward to how Google catches up with the other two providers. With that said, so you guys, I think, actually a quick question here. How many of you are using more than two of these clouds? So maybe two or more of these clouds. Interesting. So probably around 10 to 20% of the audience as well. So, and that's the trend we've been seeing. Some people like certain features from Google, some people like certain features from Azure, and then they try to mix and match. Pricing, I think all of them are kind of in the same ballpark. So usually I don't see them adopting different clouds for price, but it's mostly features, it's mostly how your developers are actually comfortable. All right. With that said, I'll get started. I think all of you guys are fairly, you're using the cloud quite a bit at this point. So I think you'll be very familiar with some of the trends that I'm going to talk about. In general, applications today, they started off with kind of a lift and shift approach where you took an application that was in a private data center, moved it to one of these public cloud environments as it is. So you essentially just virtualized the application, moved it over. At that point, you're just using the foundational components. You're using infrastructure as a service. You're using network, storage, and compute. That's all you need to run a virtual machine, right? And so that's very basic. That's your first step. Next step is where we see the platform as a service component playing a very significant role. So services like storage as a service, database as a service, caching as a service, those are very easy to consume services. And what that allows you to do is have that extra scalability built into your application. You don't have to manage a database service like a MongoDB instance. It's being provided as a service directly by these providers, so you don't have to worry about virtual machines. You don't have to worry about how you scale this up and things like that as well, right? So that's the trend we're seeing where if you ask me how to build an application today in the cloud, and if you were not doing lift and shift, you actually were building an application for the cloud, you're going to end up using both components, infrastructure as a service and platform as a service. And obviously, these are just the basic blocks. There are some new things coming along the line, like serverless architectures. If you're using containers, which is also offered as a service from AWS, Azure, and Google. So these are some of the next generation of tools that will be available for your applications. How many of you guys have used serverless architectures or containers? Not too many, few cautious hands going up. And that's the case. So it's fairly new. There are a lot of unknowns, but that is the next step. You're going to see a lot of your developers. And by the way, if you're not a developer here, go ask your developer. They're likely using it today for some basic functions at a minimum, right? So thinking about how security gets impacted because of all these new architectures is really important as well, right? So second, you need to deploy applications in the cloud, and the reason you're in the cloud in the first place is because of speed, right? These are fast-going applications. The reason you're using the cloud, because you don't have to set up a brand new data center. If you had to deploy a brand new application, it's not a 3-month wait time where you ship boxes to a colo location and then actually set up a data center over there. It literally takes 5 minutes. You have a data center built for you by AWS, and it's good to go, right? So all applications today are built for speed, and your developers are doing this today. They're trying to automate as much as possible, including the deployment, including testing and things like that. And you'll hear words like DevOps. I don't know if you guys have already adopted DevOps, but you'll hear things like that where they're using automation tools like Terraform from HashiCorp. They're using Jenkins and things like that that basically help automate that pipeline of application development, right? Third, I did poll you guys on multiple clouds. As you can see, there are like 20–25% of you who are actually using multiple clouds today. And this is going to become the norm. As I mentioned earlier, you're going to see, because there is a certain service that Azure offers better than some of the other providers, you're going to end up buying Azure as well. And sometimes it's outside of your hands. Your developers will go buy it anyway. There may be a business group within your organization, and you'll go buy that specific cloud provider, and eventually you're forced to kind of bring it into the security program that your company has, right? So all these three trends are very critical, and they're very important to keep into account as you build a security plan for your organization, right? All right. Similarly, on the cloud maturity part, right? So most organizations are in different places today, right? So first bucket here is you don't have any workloads today in the cloud. You're just about exploring how to actually start adopting the cloud, maybe thinking of some lift and shift, and you're just planning this out. You're experimenting, you're running proof of concepts. That's where this first stage is. And typically, I've seen a lot of regulated industries like financial sectors and things like that. There's a lot of proof of concepts going on, but they're still very cautious in putting some of their sensitive data and their crown jewels sitting in these public cloud providers, right? Second bucket here is implementers. Here you actually have production workloads. You're running some existing applications within these areas, and that's where you actually adopted some of the tools that AWS has. Your developers are kind of empowered to do whatever they want typically within these cloud providers, right? And third, the optimizers. This is where you're thinking, oh my God, this costs quite a bit. And so I need to start optimizing my infrastructure. I need to start optimizing my applications to make sure that I'm utilizing platform services that I was talking about earlier. I need to start automating everything. Every time there's a code change, I don't want to run through a whole bunch of workflows that take me 2 weeks to push out a code change, right? So start to build these scripts and automation, not just from the application side, but also from a security standpoint, where you're actually automating security as well, right? And so we'll talk about that as well. So just quick show of hands. I think first bucket, how many of you guys think you're there? All right, perfect. What about the second one? All right. Third? All right. So most people are in the second bucket here, which is usual, right? It's been quite a few years now we've been in the cloud side, but as I said, you're not alone if you're in the first bucket, where if you haven't actually put any workloads in the cloud, there's still a lot of organizations who are thinking about it, and there may be some hurdles that you need to get across before you get there. Now, let's think about security, right? So how do all these changes that I spoke about, the cloud maturity model, how does this impact security? There are 3 things that are really hard to get right in the cloud. First, how many vendors do you think a typical enterprise 5,000 employees plus actually has for securing the cloud? Approximately 10. 10 to 12 vendors is what they're using today. That's a lot of security vendors that you need to manage. And then when you think about it, putting together an incident that's happened, so let's say a breach happened. Now you're putting together pieces from all these different security tools that are maybe securing certain aspects of your cloud, and actually try to piece that together and trying to figure out, hey, what is that big picture? Where did it actually originate, right? Where was the attack actually? Where was the weak point in my whole development process? So all this information is really hard to put together. So your whole security approach gets very fragmented, right? Second, the attack surface has changed. So typically when you had a private data center, you had your perimeter, you had an egress pipe coming out from there, and that's where most of the attacks were coming in from. You may have insider attacks, which you can probably take care of. Now, with the public clouds, almost everything is public. That's the word. Your APIs are public. AWS, Azure, and Google have very rich APIs. Where do you think attackers are going to go? The APIs do everything for you. I can manage all the way from billing, security. I can manage the deployments. I can manage infrastructure. Everything can be done through an API programmatically, right? So that's really important to understand. The attack surface has shifted. And that's why when I say, when you do lift and shift to the cloud, don't treat your data center and the public cloud the same way from a security perspective. Think differently on what the attack surface may look like in the public cloud side. Second, I already mentioned about putting together pieces of information is a very manual, time-consuming process. What about compliance? Now when you think about standards like GDPR, how do I actually make sure that I have data that may be sensitive sitting in these cloud environments, and how do I manage compliance for these environments, right? So those are some of the things that you should also think about. How do I do it in an automated manner? Not when just an auditor shows up and that's when you run around and actually try to get the compliance figured out, right? You actually need to do it in a continuous automated manner. And then finally, the attackers typically in the public cloud environment are not very sophisticated. As I said, private data centers are very hard to get into. They're very well guarded. In the public cloud, all you need is a mistake. All the press releases you've seen out there today, Tesla's being breached, you look at some of the voter information that got out for the American population, all these are mistakes. It wasn't an advanced attack. All they were doing is running a simple script and looking for some misconfigurations that have been done within AWS, right? So it's always important to remember with human error, mistakes get amplified in the public cloud. Let me give you an example. If you actually spin up a new instance, like an EC2 instance within AWS today, you have a public IP address on that instance, and just let it be. Maybe you're running a Windows machine, a Windows virtual machine with a public IP address. You will get an attack on that interface within a few seconds. You will get a scan first, looking for open ports. If you do have an open port, within 5 to 10 seconds, you'll have an attack coming in. That's how long it takes with an instance sitting on AWS. And why is that? The public IP space of AWS is known. Everyone knows what the public IP space is. It's published, so the attackers know it as well. All you're doing is running scripts across that public IP address space and looking for open ports. That's all they want to do. And these scripts at a massive scale, remember your attackers have access to the cloud as well. So they can run thousands of these servers running these scripts, and they're scanning as fast as possible. Whoever can get in first will probably get access to the data they need, and then they can go sell it in the dark web. That's pretty much how this whole process works, right? So very important for you to remember, human error is something that you want to monitor. Your developers are not security people. They are not experts at security. So for them, just because something is faster to do, they will end up making a change that may actually compromise your whole environment. So to give you some examples, right? There are many risks. These are fundamental problems that we see, and this is data collected from Evident. And if you're not familiar with Evident, it was an acquisition we made probably around 6 months ago now. And essentially what it does was monitors for configuration changes within these public cloud environments. And so when we looked at this, it was actually almost shocking to a point where we were actually surprised how some of the fundamentals were broken, where almost half of the people got VPCs wrong. Like the ACLs on these VPCs, they were actually open. They were just using default ACLs. Multi-factor auth not enabled. That's something as basic. Make sure that all your accounts have multi-factor auth enabled. You have your crown jewels stored in these cloud accounts. So you want to be very careful with that. Poor password policies. Like really, I mean, this is really basic stuff that people should be fixing. So these are things that is really important for you guys to remember, that developers are doing most of these problems. These are just fundamentals that developers are getting wrong. And you can actually push and educate your developers with some of the basic documents that are out there. I don't know if you guys are familiar with the Center of Information Security, or Internet Security, actually, CIS. They have a benchmarking tool for AWS and Azure, and I think Google's in the works, or it's already just about published. But essentially, you can use that as a guideline. It's a framework where you can give to your developers, make sure you adhere to all these different benchmarks, and make sure you're almost compliant with all the benchmarks here. They may not be 100% compliant, but at least the critical ones are taken care of, right? Here's another set of stats, which are even more shocking. Root API keys. People are using root API keys. You should never have a reason to use root API keys. Root API keys basically give you access to your billing. It gives you access to all the infrastructure that you're running within your accounts, right? These are really basic things, and almost 10% are using root API keys. You should never have root API keys in the first place. Same with the S3 accounts. This is where all the press releases have come from, essentially. Having actually buckets open within AWS, and having a global ACL where anyone can access it over the internet. And that's a problem. And I'll give you a quick demo of that as well later on. All right. 3 things that Palo Alto Networks believes you need to get right? And this is something that drives our vision for cloud security, and you'll see all the products that we build out and add into our portfolio will essentially look at these 3 pillars for us for cloud security. First, we're a security company. We want to give you the best security that we have in the industry, and that's something that we're going to follow, right? So providing you the most advanced set of tools that help you for security. Second, we actually provide a consistent set of tools that allow you to actually use multiple clouds. And this trend is going to happen more and more. You're going to start using multiple clouds. Your developers are using it, as I said earlier. And so providing a consistent level of security across these clouds is really important. You shouldn't have to manage security differently for each one of the clouds. The level of security should be the same. And finally, this is something your developers really like, is frictionless security, right? The best security is where your developers don't even know it's on until they do a mistake, and then you go educate them about it, right? So that's the kind of security we really strive to get to, is where it's completely frictionless to deploy. All right, shared responsibility model. How many of you are familiar with this? I'm sure it's been advertised quite a bit. Everyone familiar with this? So for those who haven't seen this before, all the cloud companies keep telling you over and over again, the cloud companies will take care of your infrastructure. They'll make sure that your compute, storage, database, networking, all that stuff is taken care of. And basically, they're making sure anything that they've paid for, their physical data centers and things, and the hypervisors that they're running, stay secure, completely secure, right? Anything above that is completely your problem, right? So configurations, any virtual machines that you put up there, your own applications, your own databases, right? Access lists that are within AWS, encryption, all that stuff is your problem. The providers do not want to take liability for that, right? So it's really important to remember there is a line where they will take care of security. Do not trust the provider to do the rest for you. And that's where tools like Palo Alto Networks comes in, and you have a lot of other vendors helping you in this space as well, right, to help you secure those environments. And finally, cloud security is a team sport. Obviously, SecOps and DevOps folks are involved. Those are the guys who need to be involved for security. But the other roles are really important as well. Risk and compliance teams, we see that more and more, where larger enterprises now have dedicated teams where all they focus on is in compliance, right? If you're a smaller organization, you may not have this as a separate role, but it's going to come eventually. Eventually, you'll have at least one person focused on risk and compliance. And so make sure that people are working together as you build out your policies and things like that. And finally, the C-level folks, you don't want your name in the papers, right? So those guys obviously need to be aware of what's happening in the cloud side. How are they securing it? And how can you guarantee that I'm fully compliant and stay secure, right? So it's definitely something that people will have to work together as they build out their cloud security program. Now, I want to now point out 3 tools that you need for your cloud application. So I think I showed you this picture earlier of what a cloud application looks like, which is infrastructure as service at the top you see, essentially virtual machines running over there. You can have your app servers, web servers, and things like that. And then at the bottom, you have platform services. And there's constant communication happening between these two environments, right? Your platform services are talking to your infrastructure components as well. And how do you think of security in these environments? Typically, if you just had inline security, your platform services will be almost invisible. Inline security is typically looking at traffic flowing between virtual machines, right? And so that's why we believe there are 3 separate areas that you need to secure. And this can be Palo Alto Networks, it can be another vendor, but at least as you think about security for your cloud, 3 areas that you got to think about how to secure your cloud environment. So inline, obviously, is the first one. As traffic flows in and out of your environment, as traffic flows between virtual machines, you want to make sure that you have visibility into that traffic. You're able to prevent attacks coming in from the outside. And then also, even if you have an insider attack, then you want to make sure that the traffic that's flowing out, or the data that's flowing out of your cloud environment, is visible to you, right? So that's where the inline comes into effect. Second, you have the API-based model. As I mentioned earlier, AWS, Azure, Google, very rich APIs. You can do essentially everything, including security. And that's why we thought API is a very good place for a security tool to actually insert itself and to be able to monitor for events. And where API is really useful is data stored in platform services, which may be completely invisible to an inline tool. And so using APIs and having a security tool that leverages APIs is really important as well. And then finally, a host-based approach, having an agent that sits inside the virtual machines. So you'll have a lightweight agent. Why is lightweight important? You're paying for compute. You're paying for memory by the hour. So having a lightweight agent that doesn't have a very large footprint is really important. So when you evaluate a vendor, make sure you do that analysis of how lightweight is that agent for providing security, right? So, and this agent is providing you some really essential tools. And to give you an example, your developers are going to use open source tools all the time within these virtual machines. And vulnerabilities are going to show up eventually, right? Heartbleed happened. No one had heard about it until somebody heard about that zero-day threat that showed up. And it was essentially in the OpenSSL library. And then how do you actually now think about, you start to think about patching all the virtual machines that had this vulnerability, right? In the meantime, you have attackers looking for anything open that has these vulnerabilities. And so how do you have that active protection from the time that you find out about a vulnerability to the point where you actually look at patching? It typically can take a day or 2, depending on your level of automation, to actually patch all the thousands of workloads that you may be running here, right? So the agent is where that will help. It will essentially look at any sort of weird anomalous behavior happening within your virtual machines. Even if it's a zero-day threat, that's fine. And we'll be able to actually look at blocking any sort of weird activity. And even if you do, remember, resources in the cloud are almost like throwaway resources. If you see suspicious behavior, you have a golden image. You essentially kill that machine and start from fresh, right? That's the best way to approach these kind of security vulnerabilities. Would you want to invest time to investigate? You can do that. Your security tools will have a ton of logging that you can investigate and spend some time. But to keep your application running clean, start from fresh golden images that you trust, right? And that's really important. All right, so these are the 3 tools, obviously, we think are really, really important. And we map these 3 tools into 3 products that we offer. We have VM-Series, which is our next-gen firewall deployed today. And it's a virtualized version of a next-gen firewall, not just supporting all these cloud platforms, but we've done a lot of automation. Remember I said frictionless security, and that's really important to us. We can deploy this essentially as you build your infrastructure, VM-Series gets spun up. As you scale your infrastructure, if you're doing auto-scaling within your cloud, this will auto-scale with you, right? So we want to make sure this is completely frictionless. So if you already have Palo Alto Networks firewalls, this is kind of a no-brainer. It builds into the same management platform that you're using today. You can manage all these policies, and it's as automated as you can get, right? Second, Evident. That is using the APIs. And more recently, which we haven't obviously built an icon for because it was announced almost 6 days ago, I think, or 4 days ago, we announced the acquisition of RedLock, which is also in the space of cloud security. And for us, both those tools fit into the API bucket. And over time, obviously, we see both these tools coming together as a single tool, which will allow you to actually get full visibility into your environment. And then finally, on the host side, we have traps. Now, if you're familiar with traps, you may have heard about it mostly in the user endpoint space, where traps is running on laptops and things like that. And what we saw was a lot of our customers are already using traps for server workloads. They were using it for Windows server workloads, especially in Azure. And more recently, we now support traps in Linux environments as well. So if you're running Linux servers or Windows servers, you can run traps within those environments as well. So those are the 3 tools we provide for public cloud protection. Now, diving a little deeper into what Evident offers. Evident is API-based, agentless, so you don't need to deploy any infrastructure to get Evident running. It is fairly simple to use. It is a cloud service by itself. And the best thing out of this is it's almost near real-time detection. So if anyone configures their bucket wrong, or they change the ACL on a certain EC2 instance or a security group, we'll essentially get to know, we send an alert, and we go basically run through a workflow, right? So that's how Evident works. Essentially, we ingest a ton of logging data coming from AWS, Azure, and Google, and then we look at risks coming out from those, that ton of logging data, and then we analyze those risks and basically alert on things you should definitely know. That's how essentially what Evident does today. And today, Evident supports AWS and Azure, and Google's coming pretty soon. RedLock, on the other hand, actually supports all 3 clouds as well, right? So the other thing I want to call out is Evident automates compliance, and we'll talk about that in a little bit. Compliance is a really hard problem to solve for the public cloud. There are all these controls. You have hundreds of cloud accounts across your developers, and you're trying to map all this stuff together every time an auditor comes in, and we'll show you how to automate that. 3 broad buckets that Evident helps with. First, continuous monitoring and discovery. Second, we talk about automating compliance. And third, we talk about storage. So let's look at each one of these, right? Continuous monitoring. So what we do, as I mentioned earlier, is AWS and Azure generating a ton of logging data going into your CloudTrail logs, essentially, and we scan that, we pick that up, look for risks, and we have a very comprehensive risk engine that's looking at all of these things, right? We're looking for threats, we're looking for any misconfiguration that your developers have done. And then finally, if there is a problem, we send it over to some of the tools that you're already using today. So for example, I could create a Jira ticket that because we found something that a developer should fix. Or I would send a message on a Slack channel that you may be using today that will just talk about a certain resource that you need to pay attention, right? So that's essentially what the workflow, that's where the workflow gets kickstarted. Now, you're also using AWS functions, Lambda functions, or you may be using Azure functions. And this is where I spoke about serverless. These, if you're not familiar with Lambda or Azure functions, it's essentially a scripting engine that's running without a server. So you can write in any script that you're familiar with, maybe Python or Ruby or something like that. And essentially, you can run that script based on a certain event that comes in. And that event could actually be a risk in your environment. And so that's where you start using Lambda functions as well as Azure functions. So for example, S3 bucket is left open by a developer. That would go create a ticket. It would also send a notification to AWS's notification service, or SNS, right? And then Lambda function will pick up that notification from SNS and then kickstart these workflows. And essentially, then you're looking like a fully automated remediation model with AWS, right? So in case there is a risk, you're running through a workflow and kickstarting that. All right, on compliance, as I mentioned earlier, there are quite a few standards that you need to adhere to today, right? You have GDPR, you have the CIS benchmarks that I spoke about, which is the first icon. I didn't know they had an icon, but that's the first one over there. You had all these other standards that are out there, including PCI compliance, right? So when you're using the cloud, there are quite a few controls that you may actually be unaware of, which may map to a certain requirement within GDPR or PCI and things like that. And so how do you automate that, right? You have hundreds of counts, hundreds of controls. That's probably 10,000 things to actually look at and monitor on a continuous basis. And continuous is the key word. You don't want to do this every time an auditor comes in. You want to do this in a continuous manner so you have a scorecard, you know exactly how compliant your environment is. So that's the really key piece that Evident provides, right? In the old days, you did a spreadsheet. You had all these lists of controls. You would map it to what PCI really requires, and then you look at that and see if it's enabled, disabled within AWS, for example, encryption and things like that, right, for some of the services offered by these providers, right? And so that's where Evident completely automates that. And what you see on the right-hand side here is a very comprehensive report of all the controls within PCI, the resources that may map to those controls, and how compliant they are, right? So you see those X's on the right-hand side that essentially tell you that you're definitely not compliant. And we'll show you an overall percentage as well of how far down you are in the compliance side of the house. And you guys may follow compliance standards that we don't support today, right? And especially as we look at the international markets, for us, obviously we are unable to keep track of all these new changes that are coming into the play, especially with the public cloud. So there may be standards that we don't support out of the box, and so we help you build some of these standards on your own. So you can have that same reporting structure that I showed earlier, but based off whatever you think makes sense and the controls that you think make sense as part of that compliance standard. All right, now let's look at storage security, right? So there are a few storage services. There's AWS's S3, which you can use. There's Azure storage. There's blob storage within Azure. And then you have Google Cloud Storage, right? These three services essentially store a ton of data that may be private or public, depending on what your application looks like. And what's really important is there may be some reasons why you may need to have a public bucket, for example. You may have an S3 service that actually needs to be exposed over the internet, or you may need a group of developers to have access to it. But what you don't realize is sometimes people make mistakes. They may actually upload a spreadsheet full of credit card numbers or a database file that contains all of this sensitive information into a public bucket. And that's where you start to realize, I don't have an automated system to check that. There are scripts outside who may pick that up and actually steal that information. And that's where it's really important, where you need to be able to monitor data stored within this. Not just look at whether data is exposed or not, but also look at the type of data that is stored there. Does that data contain sensitive information? Does it have some tax IDs that they shouldn't have, right? And so you need to look at the type of data and the exposure associated with that data, right? So both those pieces are really important. And third piece here is, what about malware, right? May not be as big a problem yet, but if someone managed to, let's say you have a support ticketing application, and someone uploads a configuration file that's infected, maybe a PDF file that's infected, right? And then your support team goes ahead and downloads that PDF file. What happens then? You now have malware in your organization because you accepted input from the outside. So you need to think about malware coming in and seeping through your applications as well, and to be able to scan that and quarantine it because you found a piece of malware, right? And that's really important, and Evident Storage does that for you as well. Now, I want to give a very quick example of how easy it is for an S3 attack, and this is really interesting. I don't know how many of you use S3 today? Not too many, or a few? Perfect. So I don't know if you knew this, but the namespace, or the name of your bucket, is essentially a global name. So every AWS customer can access another bucket if they wanted to, as long as the permissions are set the right way, right? So the bucket name is actually pretty global. It's not private to your own account. And so if you actually go to a browser and type in the bucket name followed by s3.amazonaws.com, and you don't even need the last part, the object, but if you just type the first part that I showed earlier, you will be able to see whether a bucket's exposed or not. And if it is exposed, you'll get a list of all the files inside that bucket. And that's really scary, right? And so what attackers have done is automated this. There are a bunch of Ruby scripts out there and Python scripts out there that will essentially automate this for you. You can essentially look for all the possible names in the world. So maybe take a company name like Palo Alto Networks, and then you attach maybe your developer or a product name to it, and then you start scanning for things like that. So you have a dictionary of words, and then you have that script run across that dictionary of words, right? So let me show you an example here on how easy this is. So switching over to the browser here. So I just went to test123.s3.amazonaws.com. What you get back is essentially some XML code, which tells you that this bucket's protected, right? So you can't get access to it over the internet directly. Let me change that to something that's open, like public photos.s3.amazonaws.com. This is a list of files that are available. By the way, I don't own this public photos, and I checked the photos. They are okay. There's nothing that you should be worried about. This is somebody's photos uploaded in 2011, I guess. But essentially, what you're looking at is a directory structure, right? You're looking at a list of files that are available, the file types, as well as when it was uploaded, when it was modified, the size of each one of the files. All this information publicly accessible. As I said earlier, now going back to the slide here, automate this. I have a dictionary of words, like I said, public photos, and just run it across a whole bunch of organization names and developer names, product names, anything you can think of. And all you need to do at this point is get creative, right? This is how easy it is to get access to some of these buckets that are out there. So when you think about why I keep telling you about misconfigurations is a problem, this is a perfect example of how easy it is to have like a bot that does this for you in an automated manner. All right. Talking about DLP, data leakage prevention for the cloud as well. So as I said, buckets can be open, it's fine. If you really need to have a bucket open, that's okay. But you want to make sure there's no sensitive data in there. So if the exposure is public, you want to dive deeper into the type of data over there. So you want to look at, is the data PCI related, right? Does it contain a credit card number in there or multiple credit card numbers? And then if it does, let's auto-remediate that, like fully automated to the end, to a point where I remove the permission, I make it a private bucket, right? And that's really important as well. So change the access list on the bucket automatically. So this is something that Evident can also do for you as well, right? Now, we're kind of in a weird place right now. We announced the intent of RedLock last week. So the acquisition hasn't closed, and that's why I cannot share any more information than what I have on this slide. But essentially, this is just to let you know that we're really invested in security, cloud security over here, right? We spend quite a bit of money on Evident. And what they really bring to our portfolio is the automation of compliance and continuous monitoring, right? And for them, compliance was a big strength, right? Most of the customers who bought Evident, compliance was the biggest takeaway for them, and to be fully automated with GDPR and things like that. RedLock, very security focused. They have a ton of machine learning and AI and things like that inbuilt to look at not just the CloudTrail logs and just basic logs, but you can also look at other logging data. You can also ingest third-party data, and then you start correlating all this information with machine learning, and you start to look for anomalies, right? This is where RedLock really shines for us, right? And so what RedLock really brings to our portfolio is the same discovery that I spoke about, looking at resources, not just the resources within AWS and Azure, but now we have Google with RedLock as well, right? And then we look at risky configurations. We monitor for any sort of threats that we think that you should know about. And then finally, there's a whole incident management that's built into RedLock as well, similar to Evident, where you can kickstart workflows, auto-remediate as needed, right? So that's essentially what RedLock brings to the table as well. That's pretty much it on my side, just giving you an idea of all the different tools that we have, giving you an idea of all the different cloud provider areas to protect in a way, and make sure that you understand shared responsibility as well. Hope this was useful, and I'm open to taking questions. I think we have around 6 or 7 minutes more, and we can take some questions, or if you feel free to stop by as well, and we can chat some more. Any specific questions? Yep. No, so interesting question. So the question was, I did not mention Aperture, which is which is the SaaS security service, or CASB, or Cloud Access Security Broker, or however you want to call it. So that's the product we offer for securing SaaS applications. So the part where Aperture actually did a little bit of work for AWS, Azure, and Google, we are actually inheriting that into the Evident side. And so just the public cloud providers, we're pushing into the Evident side. But SaaS applications, you still need to buy Aperture, and that's the focus for Aperture. So if you look at the portfolio now, Aperture focused on SaaS, and then we have RedLock and Evident focused on AWS, Azure, and Google. Any other questions? And by the way, we have maybe 3 sessions on Aperture on Wednesday that you can attend as well, that talk about securing SaaS applications. Any other questions? All good? All right, perfect. Looks like no more questions. I'll be around here for a bit. Feel free to stop by. Thanks so much for attending. Thanks so much.